Hello there, I am François-René Rideau. I am CEO of MuKn and lead architect of the Glow language. But you can call me Faré, that's my name on Discord. Our Stu Alex Plotnik will teach you how to use Glow, our domain-specific language for decentralized applications. But first, I would like to explain to you what Glow is all about. Just what is a domain-specific language? And foremost, what is a decentralized application? You probably already have some idea of what a decentralized application is since you came to this course. But let me try to define the concept clearly. A decentralized application, or DApp, is an interaction between multiple untrusting parties exchanging assets on public ledgers subject to algorithmically verifiable rules. These are 4 conditions. First condition, it's an interaction. It may involve trading, insurance, future options, following market price charts, supply chain events, recording real estate deals or medical diagnoses and interventions, maybe even gambling. It can be any kind of commercial transaction, professional or hobby activity. Second point, untrusting. The parties may be unable to otherwise trust each other because they live in faraway countries with no available recourse in case one reneges on his obligations. Maybe one lives in Kenya and the other in Kazakhstan. Maybe their interaction is too small to justify involving lawyers. And neither of them has the means to afford a lawyer or to be worth targeting by a lawyer. In case of dispute, of course. In any case, the official enforcement mechanisms don't apply or are too expensive. Third aspect, assets. These assets may be some cryptocurrencies like Bitcoin, Ethereum, or ADA. They may be some paintings, some real estate, some cars are sold or rented, some haircuts or plumbing interventions, any goods or services that can somehow be tracked on the blockchain, be it because there are native assets on the blockchain, native tokens, or maybe some other asset that is reflected on the blockchains via some kind of centralized or decentralized oracle that says, yes, this thing, these bits here represent this asset in the real world. Fourth aspect is these interactions between untrusting parties about digital assets must be algorithmically verifiable. That means that a computer program can automatically tell whether one party followed the rules or misbehaved. And in that case, it can make the victim whole by punishing the culprit. The program that serves as an automated arbiter is called a smart contract, and it runs on a public blockchain. Both parties must trust this program, the smart contract, to enforce the proper rules. And to be able to trust the program, usually they will have to trust experts who wrote the program or audited the program and vouched for it. So that's what a decentralized application is about. Interaction between untrusting parties about digital assets or digitally represented assets with verifiably, algorithmically verifiable rules. Okay, now that we understand decentralized applications, what is a domain-specific language? A domain-specific language, or DSL, domain-specific language, is a programming language that is designed to precisely express and combine the concepts of a given domain. Compared to other languages, a DSL enables you to write programs that are simpler, safer, and more portable as long as they are about this domain. As the name implies, that it's not a general purpose programming language that can do anything. No, it's designed just for this domain. If you stick to this domain, this language will be really great. If you want to go outside this domain, you need a different language. And so, on the one hand, in Glow, you can talk about the domain concepts that matter to decentralized applications. These concepts would be participants, assets, amounts, durations, etc. These concepts are built into Glow. If you take another general purpose programming language, you have to reconstruct these concepts on top. That will take a lot of effort, and that will be the opportunity for a lot of bugs. In Glow, you can directly manipulate these notions. On the other hand, in Glow, you don't have to think about all these implementation details that are not interesting from the commercial point of view of the user of Glow, the person who wants to write an interaction between interesting parties with digital assets. So you don't have to think about all these implementation details that are not about the thing that matters to you. And a lower level language would force you to deal with these details. And these details would be things like sending and receiving messages made of bits and bytes over the network and making sure they arrive at the right place. Other details would be managing keys so that there is no mix-up who signs and sends what messages to whom. Or it can be inverting the control flow into data flow so you can relate the sequence of messages to a same interaction. That's something that programmers do a lot, especially when they have to translate these high-level concepts into low-level details. You don't have to handle timeouts so that funds are not lost when one participant stops cooperating. Once again, something that you have to deal with if you're using Solidity or a low-level language. Other details are synchronizing the behavior between your off-chain client and the on-chain smart contract. That's also something you have to do by hand if you use Solidity and other languages like that. And you can have plenty of other details such as escrowing the sufficient collateral to keep every participant honest, etc., etc. There are so many details that you have to get right when you write a smart contract. And these details can be totally done for you using Glow, or you can do them manually using another language, in which case, good luck to get everything right. And so because with Glow or with a proper DSL, you don't have to deal with these implementation details. Your programs can be much simpler. You don't have to think about the details. It's not just simpler, but it's also easier and faster and cheaper to write your programs, to understand your programs and the programs of other people, to audit these programs, and to trust these programs. If you have a 10-line program, it's much easier to understand what's going on than if you have a 100-line program or a 1,000-line program. That's why a DSL is so much better in every way. It also frees your mind because you don't have to deal with those details. Your brain is finite. My brain is finite. I don't know, maybe you are a genius, but then you don't need a DSL. But if you're not a genius, if like me, you're just a normal person, you can just think about more things when you don't have to think about the low-level details. You can free your imagination and build more elaborate applications. If to build the same application, you require only 10,000 lines instead of 100,000 lines, then suddenly, wow, you can build that application that would not have been able to write otherwise. Or an application that with current tools would take millions of lines, and now it only takes hundreds of thousands of lines. Now with a team of a few people, you can write it. Otherwise, it would have been impossible to write and maintain and make sure that it doesn't fall apart. So a DSL can enable you to do things that you would not have been able to do otherwise. That's the power of simplicity. Smart contracts written in Solidity have lost hundreds of millions of dollars worth in assets due to reentrancy bugs, misauthentication bugs, unbalanced accounting bugs, library destruction bugs, etc. These are bugs that are not even possible to express in Glow. They involve low-level implementation details in Solidity for which a programmer failed to consider some case, sometimes subtle, sometimes not so. But Glow abstracts away these details and automatically covers all the cases for you, subtle or not. Not having to get the details right means much fewer opportunities to get them wrong. Glow programs are not only an order of magnitude simpler than their equivalent in Solidity plus JavaScript, they are an order of magnitude safer, and for the same reason. Of course, you will have to trust the Glow compiler to be correct, but the Glow compiler is also written using safer and simpler tools than Solidity, for instance. That's why the Glow compiler is already more than 10 times smaller than Solidity. And that's why it will be much easier to write, audit, and trust Glow than it is to write, audit, and trust Solidity. Portability. A DSL abstracts away implementation details so you can focus on the essential concepts of its domain. Then, the language can be adapted to run in very different environments. Thus, the Glow compiler can be adapted to run on any blockchain, and the program written in Glow can run on any blockchain supported by the Glow compiler. By contrast, most or all smart contract languages only run on a single blockchain, and its clones, if any. If you write a smart contract in Solidity, it will only run on Ethereum and its variants. Similarly, Plutus will let you write code only for Cardano, CashScript only for Bitcoin Cash, etc. Whatever you use will work only on one type of blockchain. And then you'll need also to write your off-chain client programs, also in a different language with a different API. All your efforts, you'll have to work 10 times more to support only a tenth or less of the ecosystem. Like in terms of effort to result to effort ratio, like you can do 100 times better by using Glow or with language like Glow, if there is any. There is none right now. And so, using Glow, you can concentrate on just writing your program. It's just like using assembly instead of binary code, or using C instead of assembly, or Python instead of C, or Lisp instead of Python. Each higher level language abstracts away some low level details from previous languages that are now efficiently handled by its compiler, so you don't have to deal with them. Thus, your decentralized applications can be simpler, safer, and more portable. They will be cheaper to build and easier to trust, because you can focus on the essential concepts that matter, while Glow handles implementation details for you. As of today, the Glow compiler only supports Ethereum and Cardano and their variants, but we're actively working on supporting more. If there's a blockchain that you would like Glow to support next, let us know. The Glow language can already be used to write many useful decentralized applications. Yet, we have many plans for how to improve it, and we are working hard to extend it so that Glow will support all the decentralized applications that matter. Is there a specific DApp that you would like to write for which today's Glow is insufficient? Again, let us know. We invite you to fill our questionnaire linked below and tell us what is important to you so we can better prioritize which features to implement next. Now I'm going to hand things over to our CTO, Alex Plotnick, who's going to lead the lectures. I'll be around to answer questions and help out though, so I'll see you all soon. Thanks and goodbye.